those if you've not already. So with the rest of the time this evening, really, I was hoping we could talk some about projects. Originally, we were going to try to address projects in January, and as the world goes, we went ahead and pivoted this into a February meeting. This is all pretty common for us, really, to start thinking about projects in February. It gives us time to ramp up and get ready for spring. And for so many of us, getting kids outside, whether they're collecting field data or doing a neighborhood inventory or whatever they're doing, the ability to get outside is not too far away. At least that's what I'm going to tell myself as I sit in 8-degree weather. So it's a good time to start preparing. So this is why we tend to talk and think about projects in the middle of winter. I guess we're kind of like Target like that, right? We're rolling out our spring apparel well ahead of spring actually starting. So when we think about tools, and I'll mention this once, and then we've got two great presenters with us this evening, who I think most of you probably already know. Each of them will have about 5 minutes to share probably one project that their kids are doing. And we'll visit that in a minute. But when we think about the tools that are most often used, not always, but most often, they tend to resonate in ArcGIS Online, right? We know these. Survey123. We use that for data collection. We use that for data collection largely because we can control the fidelity of the data collection process using drop-down menus, concise location, if that's what we want, street address for location, but we can also include things like files. You want to do a bird call, we can collect that right inside of Survey123, and when the student submits it, that audio file gets submitted and hosted in your service. That data can be essentially controlled, right? We can set limits on what we're expecting to see, and then we can draw it out and analyze it in nearly real time. So in addition, the Survey123 is kind of that front-end data collection piece. We've got, of course, StoryMaps for presenting it, presenting our work, presenting a final product. And then, of course, we've got other tools like the map viewer and dashboard for both analyzing and visualizing that data. So there's there's a wide range of tools that can be used to support different aspects of project work. And of course, some people will use Pro. They'll focus their work with Pro mostly on analysis. And of course, with Pro, you can then publish it to online if that's your goal. Finally, one thing I think worth noting that we don't often think about, but it's increasingly gaining some popularity, is using drones to support data collection. It may be as simple as shooting new drone-based imagery of a campus or your field research area, and then using that as essentially a high-resolution, very up-to-date imagery upon which you drop other data that you might be collecting in your field projects. So there's a couple of really useful pieces of software that can support different aspects of this kind of work. Again, all of that should be included, I think, in everybody's licensing that's on the call here. So it's nothing new. GeoProjects, if you've not seen these before, they've been around a while, but essentially they're pre-built projects. They're pre-built methods for collecting data and rendering it back. The nice thing about these is, as an educator, you can just get in and use these. Your kids can submit data and you can move on. The idea being that kids are exposed to using forms to collect data in a structured way, and then they can see that data outputted on a map in real time. And frequently they can be sort of trivial in terms of the content, but what we're trying to do is not let the content get in the way of the workflow and the process of collecting data, asking questions, and then trying to make statements based on spatial patterns in the data. So there are both simple and complex uh, GeoProjects in terms of the content that's available. Last but not least for me, and then I think we'll pivot to Chris Bunin after this slide. But I wanted to call your attention to iNaturalist. Uh, Late last summer, Esri formed a collaboration with a nonprofit called iNaturalist. iNaturalist collects space data about living species around the world, all kinds of data. iNaturalist has God, like 900 million data points or something insane like this, and almost a million people collecting data globally. All this data goes into the iNaturalist system. Previously, you could get this data into ArcGIS, but it required extracting it, exporting it from their system, doing some data processing, and then ingesting it into ArcGIS Online. So you could see it, but it was a fair bit of effort, and it was a manual process. So what's happened now is Esri is essentially creating a quasi-dynamic service where they essentially update it monthly with research grade data from iNaturalist, and it will allow you to explore reports from that data set. So this link, I'm sorry, this briefing has both a link to a live map, but also to this iNaturalist Explorer, which I'll take just a quick look at here. And then we'll pivot over to Chris. For those of you that teach science, particularly have an eye towards, say, environmental science, this is just a massive data set of citizen collected um, scientific data. And it's all been vetted through the iNaturalist process, right? So to become research grade in iNaturalist, you have to have a couple of researchers, um, validate the findings that you've contributed. And in most cases, the contributors are submitting, say, a photograph or an audio file of whatever they found. So any given place in the country, somebody submitted a piece of data. I just clicked on a point, and in this case, it's some vegetation. So it's in the Living Atlas of the World. It's available for your use in any of your work. Um, Probably the biggest challenge with it is sorting through just the massive size of it. So what you've seen so far are GeoProjects, which are really collaborative projects, but they're relatively small and simplistic. And you've seen a citizen science project, in this case, iNaturalist, where project data is being collected around the world by lots and lots of folks generating lots and lots of data. Now, when we think about projects, what we want to do is pivot closer to the classroom, and we'll have Chris Bunin, who I think many of you know. Chris today teaches both social studies and CTE, really. At least that's how I would describe it. I don't know, Chris, is that fair to say?
On one, yeah, hold on one second. Yeah, sorry, I was just getting everything connected. Yeah, I was about to share that I have a really unique, ideal uh, place with GIS. My love is history and geography, and so I teach world history, AP Human Geography, and dual enrollment in GIS in my high school. So I get to weave it all together in a lot of different ways. I get to bring things from my core class, social science, into GIS. I get to bring GIS into my core social science classes. So do I have the power to
Well,
share, Tom?
well, that's a great question. Give it a
Looks like I do.
That's wonderful.
That
Give
is
it a
a good thing,
try.
right?
It is, it
Okay.
is.
All right. So thank you. Tom asked me to just share a couple of ways that I'm able to bring projects into the classroom. I thought I'd share, the elephant in the room with a lot of classes is time. And so in my core classes, I really lean on geo inquiries. I love how it teaches students how to use uh, relatively advanced web GIS. But one project that I use in all of my social science classes, world history, US history, and AP human geography, is teaching students how to use Survey123 and ArcGIS Online to explore the geography of a recipe. So it ties in nicely with this history of agriculture, the Great Exchange or the Columbian Exchange, depending on how you reference it. And so I just think when I think of how every evening in our house is a history lesson, I think of Taco Tuesday. And that is LeBron James's trademark, but I'm going to use it tonight. So the way the activity starts out is that we start with introducing students to the Great Exchange using the U.S. History Geo Inquiry, the Great Exchange. Give them about 10, 15 minutes to work through it independently. We are a one-to-one school, so we're able to do that. And then we review it. And I hear just a couple of pictures of students there, me presenting the highlights of the activity. And what I really like is students get to work through it is they really do have a lot of aha moments as they're looking at the births and diffusion of agricultural products such as corn. Here where it shows the corn belt there on the map on the image to the left. We then extend the project where I created a Survey123 where students pick a recipe of their choice. I do tell them it has to have at least 7 ingredients, and they go through the survey and they quickly research where did this ingredient of my favorite recipe originate. And again, there will be conflicts because there were eggs everywhere. There will be conflicts because there were onions everywhere. And I tell them, well, think which one would your recipe um, use for the hearth? Um, they start off with a blank map, and by the end of the map, this is one classroom's ingredients. They see this crazy network or points. The glowing points is the hearth of the recipe versus the hearth of the ingredients. So we can start to discuss, well, why would the ingredients be in the United States more in Western Europe and in the Americas? But look at where the ingredients are. And then you can go add some layers from ArcGIS, such as world regions, or in this case, the layers showing you the Silk Roads. And the students can start to see the connections between the trade networks and the recipes that they're mapping. We then have the students take that and take their research, and we throw in the origin to destination analysis tool so they can see what's the relationship between where my recipe was created and where my ingredients are from. And this student here was a student who's originally from Tanzania. And what was very interesting while he mapped Maharage is that there's not an ingredient native to Tanzania, and it literally shows the Silk Road as he maps out his recipe. They then spin it into a story map, and I do take some time. It's a simple story map. It's like 3 slots. Pretty much, this was using the map journal at the time for this image, but it was tell me the history of your recipe through the map, and then find 3 did you know map notes and drop them in, and now they'd be sketch notes into the story map. So this case here, the student mapped out, sorry, I got my head in there, or I'm sorry, my screen. But as this person was looking at hamburger pie and found that casserole, the word is a French word for saucepan. This is another introduction to the French story map. And what I like about this one is that the student was able to say, I remember my grandmother making it as a kid. So if you think about making things student centered, we all like food, right? So this is what a project I do in all of my core classes. And sometimes this spins off to allow students to do historical GIS by coming to GIS during office hours or doing it in a class. And so, oh, sorry, one more thing. Here's the heat map of all the ingredients of this one class. What I like too is we talk about ancient agricultural hearths, but it's not the map the textbook's giving them. This is informed by real-time research that they do in the classroom. Sometimes, though, the students will do historical GIS projects outside of my class. And so this is one where a student researched the geography and impact of HBCUs for his African American history class in my high school. And so I was like happy to support you in your project. And you can see that he created a story map using the new story map platform. He researched where HBCUs are located and the relationship between that and the 1890 census data. He then looked at where the HBCUs in Virginia's alumni centers are. And again, he used that origin to destination analysis tool to show the geographic reach of this HBCU schools. This research was so powerful that I am also co-coordinator for the Virginia Geographic Alliance. And we've been wanting to create a geo inquiry to teach about HBCUs because it's a new standard in our state standards. And so we used his research with his permission and support. And sorry, I thought I had it. We split it into a geo inquiry. So we now have a statewide HBCU geo inquiry where his research helped inform us and we wrote curriculum. And I thought I had it in here, but I didn't have the geo inquiry to show you. And then I caught an audible at the end because Tom did bring up drones. So I wanted to show you one way that my students in my GIS class used drones this past spring. So we use drones and we use drone to map to capture a true ortho of Albemarle High School. And you can see that over here in this inset map. And then students were asked to pick a challenge or a problem on our campus. And so this student looked at erosion spots on campus using supervised classification based on drone footage that we captured in real time. So this just shows you the student looking and saying, here are some big erosion areas. Although I did have to tell him that area 2 is the baseball infield, and that's not erosion, that's sand that belongs on the baseball field. So I just wanted to show you a few ways that we do use GIS for projects at Albemarle High School. So thank you for your time.
That's great, Chris. That's absolutely awesome. As usual. Let's pivot over to Eric Cromwell, and we'll have some time, I think, for some questions if y'all want to talk more with either one of the presenters here. We're finished up. Eric is, I don't know, I've known you for, like, it feels like forever, but you're the science coordinator, elementary science coordinator, right? You're at Baltimore still?
Yeah, Baltimore County Public Schools. Baltimore County Public Schools is everything but Baltimore City. So we surround the city on three sides. Yeah, so I'm the K-5 elementary science coordinator, and I get the pleasure because of so much of the work that I've been interested in for the last 20 plus years has been GIS, and is we've wanted to empower students locally, and so a lot of our projects are very much based on doing place-based learning. And so on the screen is the QR code to our environmental empowerment atlas. And this has been a project that we've been working on for about 3 years now. And we're rewriting an entire series of units from K to 8, all along the lines of empowering students to make environmental change in their community. And so each of these apps are aligned to various aspects of our curriculum. And right now it's just the K-5 part. We just started the middle school portion this year, and we're leveraging OpenSciEd as the base for that. But the nice thing with OpenSciEd is you get to tweak it. So you can make it your own. You can make it local as much as you want. So the first one I'll show you is Maryland Schools and Parks. We actually have our kindergarten students talk about what the needs of plants and animals are. And one of the things they do is they are either advocating to improve the biodiversity in their on their schoolyard or at a local park. And so the way we set this one up is they look at the park nearest them, and we set it to 0.5 miles, which is basically a 10-minute walk. And one of the things we're rooting this in is an equity issue where not everybody has equal access to parks within a walkable distance of the community. And so for Cromwell Valley Park, no relation, Cromwell Valley Elementary, their closest park is actually about 0.9 miles away, which is Hampton Historical Park, which is our only national park in Baltimore County. So the students, one of the things this is doing is exposing students to the parks in their area, and then they use that park then as the basis for. So basically, they would zoom in on that park and then say, what can we do to improve the biodiversity in that park, and where can we find food, water, shelter, and space for the various plants and animals in that area. The unit's topic is squirrels and oak trees, and the unit title is Squirrel. And every kindergarten teacher I've talked to said that is the perfect title for a kindergarten unit. Tom's laughing. I think he's experiencing fatherhood. In grade 1, we have our feathered phenomena unit, and I was glad that you brought in the citizen science project. So we incorporated Cornell University's data into this, and so a school can look up their school. So in this part, I'm looking up Summit Park Elementary School. Go back in there. It zooms in, and then we grab. Why is it going back up? We grabbed Cornell University's data, their Nestbox Watch program, which is great for our alignment to our first grade standards, because we talk about nesting birds and the things they do to protect their young. And so in this app, we expose students to, so we click on a box and it says what bird is there, and then they can actually click on that bird and Cornell's website pops up. You get an image of the bird, and then it gives you all the information for that bird in that spot. And teachers were telling me how many different bird calls the kids could identify once they started to engage with this. I mean, it became center time for them. These kids they really got wrapped up in birds. And so schools are then putting up nest boxes, and so the maps become a means to an end for us. In third grade, we have we have an entire unit called Stream Doctors. We're actually just wrapping up the pilot at this point. And by the end of the unit, the students have to evaluate different ways of improving the environment. Is one of the standards in the next gens. And in this case, we've centered it on all of the stream restoration projects that occur within an area. And so we pulled all of the data from DNR, Maryland Environmental Service, and every other thing we could find. And so now, a school like Arbutus Elementary can zoom in and they can see every single rain barrel that's in their community. And then when they click on the dashboard, it'll tell them what a rain barrel does. And so now the kids get to talk about, they know their community, they know what's around, and is this actually helping to improve their community or not? One of the things that came out when we interviewed our students, and I was glad to hear we talked about HBCUs, we actually brought the data from our student interviews to our HBCU. And one of the things they brought up is so many communities of color see these stream restoration or watershed restoration projects as being things that are done to them and not for them. And so part of the aspect of this project is for them to also understand what these stream and watershed restoration projects are doing for their community. And we root it back into the water quality they have in their area. The big one we're working on right now is a unit called Trees Mend Us in grade 5, where we look at the interrelationship of various Earth systems and how they all are centered, at least in one example, on trees. And so we looked at one of the equity issues that we have that's come out in recent years is the concern about where trees exist and where they don't, related to socioeconomic status and race. And so we had the students look at atmosphere. And so in this case, we look at the heat islands effect as an example of how the atmosphere is impacting communities and where trees are and where they are not. And when you zoom in, you'll see where the forested areas are, and it takes a second or two because it's a big data set to pop up. But you'll see the forested areas in relation to these heat islands. And then that story map continues down through. Yeah. And so, you'll see these heat islands pop up here with the forested areas. And so where there's more forested areas, you have a lower heat island effect. Then we have hydrosphere, and some of this is callback to what we do in grade 3 with streams. We look at where forest and trees are in relation to high water quality. So with this one, we look at the Maryland Biological Stream Survey data, and they have every single stream mapped out and the data associated with the water quality. So I can look at a stream like this one and say, all right, what's the water quality? And I can look at that. So this has very low water quality. And then, okay, there's not a lot of trees around it. So is there a relationship there? So we then even go back to kindergarten with squirrel, and we look at the relationship between different species of squirrels and the types of trees that are growing there. So each one of these maps has each of the predominant squirrel species in the state. So it's a real callback for us, which is timely because this one really is coming up on our state assessment as well. Obviously, the outcome for this one is getting kids to plant trees in their community. So it's, again, a means to an end. Our flagship project, which Tom, you effectively just changed inside of 5 minutes that iNaturalist thing. I'm now going to have to upgrade our project because that just made my world a heck of a lot easier. You have no idea what you've just done. Like tomorrow, our project's going to change. So when I saw the pie charts, I had to laugh. We've been doing this project for about 7 years now, and we send students into the field with GPS-enabled tablets, Samsung tablets. We've had them collect about 120,000 points of data. So if I zoom into Cromwell Valley Park, again, no relation. These are all of the data points our students have collected. And as you can see, we can now do habitat analysis. So if I zoom into this field, I can see, okay, what's the biodiversity of this area in relation to, now I can zoom over here and now I see what it looks like in a forest and I can see how that changes. The baseline data is, this is all the baseline data from the parks. And so we not only did that, but we also did all the schoolyards. One of the upsides to COVID was we did all of the schoolyards as well. And so we have a baseline for that. So their project is, what can we do to improve the biodiversity on our schoolyard in comparison to our parks? So that project just officially changed with iNaturalist because now we have a much more sustainable project with all kinds of extra data. So that'll be my fun for tomorrow. Thank you, Tom.
Anytime. That is incredible. The breadth and depth of project work that you have led in that school district is just amazing.
Well, it's good to be the king. So if you're interested, all the units we've put together at this point, aside from Stream Doctors, are available. So if you want the QR code, those are all the units you can download and you get access to all the maps and how to use them with students as well. And so units from kindergarten to 5th grade.